Hey everybody, it's teardown time again. On the menu today is a digital linear tape DLT tape drive made by Compaq, or actually it's labeled by Compaq. I'll get more into that in a while. And this one has the capacity of putting a tape in here of 15 gigabyte standard capacity, or you could do 30 gigabyte compressed. And I already received it like this with the lid taken off, and then you can see the tape drive mechanism in here. We got a power supply right there, and just some big fat ribbon cables going to a couple of SCSI connectors back there. Now this thing on the bottom of it has an inspection sticker. You can see it right there. Inspected on December 14th, 2001. And so that makes it 13 years old, almost 13. And you'd think it'd be a really antique piece of technology that nobody uses anymore. But in fact, tape drives like this are still available, albeit with much greater capacity storage that you can put on the tapes. But tape drives are the way to go if you want to do very large capacity computer backup of all your hard drive or critical information. They ain't cheap though. It's like $1,000 or $2,000 for a brand new tape drive. It stores information on something like this. This is let me pull this off. This is a tape cassette. This one's actually BASF 210 megabyte only. This is an older one from like the 80s, whereas that one that we saw, that's from 2001. Anyway, but this doesn't fit in there, but we can at least have a look at this and see what kind of tape that this thing takes, and how it actually pulls the tape into the machine and gets it going and records and read information on the tape itself. Alright, now this DLT tape trademark is owned by this Quantum Corporation, and they license the technology to a whole bunch of different manufacturers. In this case, we're looking at Compaq. And this is just a few pages that I printed out of their 219-page PDF, explaining all sorts of things about different tape drive technologies and different methods of recording the data, and cost-benefit analysis and a whole bunch of other stuff. Anyway, just a few pages here explaining some stuff. This is basically what's inside the tape drive, or at least this portion right here. This is the tape, the take-up reel itself, and then we got these 6 spindles, and then there's the read-write head right here. And then the tape cassette, something like this, goes right there. Now the cassette itself is just a single reel of tape on the inside, and it's not a double reel like a VHS cassette tape. There's a locking button right there, so if that button is not depressed, and I can't turn it and accidentally pull the end of the tape out of here, so I made this thing with a steel bar and a couple of neodymium magnets and a little nut right in the middle. That nut pushes on the button, and the magnets, of course, hold on to the steel washer attached to the tape spindle. Now I can actually pull this out a little bit. So there we go. Now the way this thing works is that when before you put it into the machine, there's supposed to be a drive leader. This big plastic strip right here is supposed to be already in place, and a little hook just holding in place and ready to receive the end of the tape, so that when you put the tape cassette in there, of course this will be all rolled back up inside. So you stick it in there, and then this thing grabs a hold and starts yanking this thing through, going past all the rollers and past the head, and then onto the take-up reel, and just starts winding it on the take-up reel, and then reading or writing the data. And by the way, these pictures show 2 different types. This is a different type that I don't have inside the machine. What we are looking at is this type with the 6 reels. Now the tape itself is exactly a 1/2 inch wide. That's the default standard 1/2 inch wide tape. And they can store many different tracks on there, like 100 or 200 individual tracks of data, very fine tracks going along the whole length. Some technologies just record the data in straight parallel rows like that, going all the way across. It'll read, one way, and then shift the head a little tiny bit up or down to move the individual magnetic elements to a different track, and then read or write data in that other different track. There's some other technology which actually tilts the head left or right like that in order to make something like this herringbone pattern. And with this kind of pattern, you can get a much greater storage capacity than you can with just the parallel rows of tracks like that. You can just see 1.75 mils for this single row of information right here. Very fine track. And then there's the other way, 3 mils per track, and then there's some dead space in between the individual tracks. With this kind of technology, you need no dead space. Now, as for what kind of thing that's going to be inside the one we're taking apart today, I don't know. I'm pretty sure it might be this one, just straight up and down movement of the head. I'm not quite sure yet if we're going to get the tilting action. Alright, now let's have a look at the actual device. This is the first time I'm plugging it in. There's a switch in the back. I'm going to flip that switch. And there we got something happening. The fan's going, lights are blinking. There's the spindle spinning, trying to pull a tape into it, but there's really nothing to pull because I don't have a tape that actually fits inside. So it looks like it tried 3 times and failed. Looks like it's trying again. Okay, after about a minute of trying and failing repeatedly, it finally reached a steady state condition where it just flashes all these all these indicator lights, and there's a solenoid in here that got pulled in and remains pulled in. Now, there's something about this particular tape drive that I should point out, is that it does not have a leader, a tape leader like we saw in one of these pictures here. This piece of plastic strip that is permanently fixed to the disc right here, and then comes out and is held in place by this hook, which is actually this thing right in there. That hook is supposed to latch on to this leader strip, but there is no leader strip to speak of in this device. It must have broken off at some point, and that's probably why I got it like this with the lid taken off, because whoever had it, they must have tried to crack it open and find out what was wrong, and they found that the leader strip was gone, and so this was totally worthless. Couldn't use it anymore. Now, the tape's supposed to go in, and with that solenoid pulled back. Is it pulled back? Yeah, it's pulled back. Oh, I remember now. Gotta put this thing up. Then I can open up the door. And maybe if I just stick my fingers in here to close some sensor switches so that it thinks that there's actually a tape in there, maybe I can get something happening here. Or maybe not. Now, without a tape in there, without a real, genuine tape, I can't get much going on here. I can do the density select, 2.6 gigabyte or 6, 10, 15, and then compress to, compress to double of whatever these numbers are. So, maximum of 30 gigabyte with this drive. Alright, enough playing around with this thing. Let's void the warranty. Oh yeah. Man, this thing is built like a tank. In order for me to get this tape drive out of here, I have to first remove the power supply, and there is a single screw up here. I pulled that out, and that's just a shield, really, on the power supply box. Nice thick copper sheet right here stuck on the inside of this galvanized steel plate. Really fancy finish on here. It's no wonder these things cost $1 or $2 grand. And that's today. And even back when this thing was manufactured, it probably would have cost $1 or $2 grand. So there it is out of the box, and there's a power supply. And I'm starting to think this thing was manufactured in '97 rather than in 2001. Partly because of the serial number down here where it says 9745. I'm just guessing that they incorporated the week of manufacture into the serial number, and that 97 is consistent with this 9700 on the transformer, and there's a 9716 on top of the capacitor there. And where else? Well, here's on this what is that? Is that a oh, that's a X2. It's a class X2 cap, and this has a date code of 7232. So I'm not so sure about that. This thing couldn't be made in 1972, really, and then actually used in a device 25 years later. Not so sure about that. But we'll have a better look on the inside of this thing, which, by the way, is still tethered to the case with this cable. Let me yank that out here. I don't know, I can't yank it out yet because this, oh, there we go. So I got that out. Now that goes to this thing in the back. This little number selector switch. So it goes from 0 to up to 7, anywhere from 0 to 7. I have no idea what it's for, but it's back here. Now I want to get this plastic case off, and it seems to be very easy. Just got to avoid this warranty, another warranty right back here in the back, and then there's 2 little hooks. Stick a screwdriver down there and pry up this one too, and then hopefully this whole thing should just come up. Yep, there we go. Good quality polystyrene right there. And so now we can get a good look at the inside. There's a single screw right down the middle. Gonna take that out, and we can see inside the take-up reel here. So clearly the tape leader is not anywhere in here. There's no, it's not like it's rolled up in the middle of it. It was probably right there in that little slot that goes back here, and it probably latched onto that little hook right there, and it's just completely gone. It must have fallen out at one point in time, and it came out with the cassette tape, and that was the end of that. So, and oh yeah, there's these little things cut out here just for balancing it, because this thing did manage to get up to fairly high speeds, and so you would certainly want it to be perfectly balanced when it's spinning at that fast. So I've been taking out screws top and bottom, left and right, and I even took the bottom plate, that thing right back there, took it off of to expose the circuit board here, because I'm going to have to undo a lot of these connectors in order to pull all these pieces apart. Anyway, check this out. Sneaky bastards hid some screws right underneath here, apparently for keeping the front panel in place. And yep, sure enough, front panel's coming off. There we go. Still got the connectors on here for all the LEDs and the buttons. Even has a little piezoelectric beeper right there. Alright, let's have a look at the belly of this beast. Get these connectors off of here. There we go. Man, this board is packed. Alright, so here's a closer look at the board. We got an Intel chip up here, 80C196, and a whole bunch of other big mess of chips. Most of these things I'm not going to bother looking up what they are. I don't even know what they are just by looking at them. These look like they're memory. We got some quartz crystal oscillators right here. This one, certainly the UCN 5804, that's a motor driver right there. And that went to this connector for the stepper motor that moves the head, the read-write head, up and down to record on all the different tracks on the tape. These other two sets of headers right here, they went to these connectors, which go to the two different drive motors, and there's no other big powerful motor drivers on here, and that's because I think these are strictly for outputting data to the motor drivers that are mounted directly on these boards, because there's some big beefy copper wire in here, so it certainly makes sense to put the motor driver for these things as close to the coils as possible. There's also this little shielded box right down here. This thing was on top of it, pulled it off already, and probably a couple of differential amplifiers, I don't know, but those go right to this connector right here with a nice shielded box all around it, and what was hooked onto there was one of these special connectors that go to the head, and that would have been this one right here with the single row of holes there, the single row of pins, and that's also shielded, in contrast to the other one with two rows there and no special shielding on there. And that was hooked up to this, oh, actually it says write head, so clearly that would be for the writing, and this one labeled right here for the reading, because this thing would write data with the write head, and then immediately after the data was written on the tape, as it's moving past all these magnetic elements, then it would read the data with these things just to make sure that it got written correctly. The board, you can see right here, as a L1 and then a faint L2 underneath that. On the other side it goes all the way to L6. So it's a 6-layer board, and I've noticed quite a few date codes here from 1997. There's another 97, and well, copyright 1986, that don't count. But yeah, there's more 97s right here, all over the place. So clearly this thing was manufactured in 97. Even the solenoid on the tape accepting box, there we go, 9721. So I don't know why it took 4 years for this thing to be accepted in 2001 after the manufacture date of 97. Accepted by whom? By Compaq? I don't know. Now here's the thing that would grab onto the tape itself, the tape reel. I took off the screw that's in there and released a rather powerful spring, and anyway, there's all these teeth right here which would latch onto the teeth on the tape. Now of course this is an older one made for a different tape drive, so they don't really fit, but anyway, that's how this thing would grab on and get a real good hold of the tape reel inside the cassette. Now in the cassette slot, there are just 3 parts that I wanted to get out, and that was this solenoid right here and 2 of these things. And I knew they were some kind of sensor. I didn't know what kind at first. I thought they were IR emitter detector pairs, or maybe one was an emitter, the other was a detector, because they were on opposite sides of the slot. But upon further inspection, I saw that it says, if it will focus, it says micro switch right there on the top of it, and some obscure part number, and again a 1997 date code. But anyway, I couldn't find anything on that part number, and really not any kind of window for IR light to shine through. So I was thinking it would be a reed switch in there, maybe a single pole double throw reed switch. So I plugged some wires in it like this and hooked it up to my DMM and put magnetic field on it with this, and I got nothing. There was no closed circuit or open circuit or anything like that between any of these wires. So apparently I can only guess it's just a little bit more sophisticated magnetic sensor where you give it power and ground, and then it outputs a high or a low 5 volt or 0 volt output on one of these wires if the presence of a magnetic field exceeds a certain pre-programmed amount. And how do I know it's magnetic field in the first place? Well, because this one was inside the slot right here, and you can see attached to the door is this little thing here with a couple of magnets on there, and the other one was mounted on this side, and it was inside this contraption in such a way that it was right at the end of the piston of the solenoid, like so. So when the solenoid was actually activated, making a magnetic field, then this thing sensed it, and it could sense that the solenoid was actually turned on. Now, going back to the main chassis here, I found something quite unusual. Screwed into these two holes right here was this thing, apparently a thermal cutoff switch. And not sure what the temperature of it is, but there's the part number, L145. Is that degrees Celsius or degrees Fahrenheit? I don't know. But it was right here, kind of centrally located between the two main drive motors and the motor, the stepper motor that moves the head up and down. So I guess if one of these motors gets physically stuck but the coils are still on, then it would overheat the whole chassis, and somehow, you know, the heat would make its way back to this thing, and that would go to a logic circuit on this main board, which would of course shut everything down. I just thought it was really weird that you would find such a industrial scale part inside a somewhat delicate, kind of very sophisticated computer device. Now then, got these motors out of here, just 3 screws in each one on the big aluminum chassis of the whole motor assembly, and there you can see that's the motor driver right there with all the data cable coming up here. Yep, we got some flyback diodes here, 1 pair of diodes for each of the 3 phases going around here. There's 9 individual coils you can see underneath the aluminum cap, and it's even got a nice part number right there. Actually, I think I was mistaken about the number of coils. The individual coils there are much thinner than I thought they were, so that's going to be 18 coils instead of just 9. And there's a nice permanent magnet in there for the spindle. And that's as far as I'm going to go with these 2 motors. I think I'd much rather have them in working order for some project that they might come in handy in the future if I can get them, if I can, you know, reverse engineer what kind of highs and lows I need to put on these things to make these things spin at whatever speed that I need. And these are fairly standard construction anyway, whether you're taking apart a floppy drive or a CD-ROM drive or a hard drive, or in this case a tape drive. You know, these very, very common kind of thing where you got the data connection to the main circuit board, and then there's the motor driver on the motor board, and all those coils, and a fixed permanent magnet rotor spinning around. So that's, you know, it's all very, very typical kind of construction. Now, the part we've all been waiting for, saved the best for last, the tape guide and head assembly. One thing I've noticed that I haven't seen before is this thing right here. Very, very fine optical encoder disc. Maybe you can just about make out the individual grooves there inside individual slots going through that thin steel sheet. And of course there's a emitter and detector on either side of this plastic housing here. And also the magnetic head assembly that just goes up and down. You can see the helical rod in there, and if I rotate the shaft of the stepper motor on the bottom, then you can see how this thing just moves up and down. So certainly no tilting capability on this. This just goes up and down for writing the data in straight parallel lines on the tape. So I took those black plastic covers off of it, and there you can see a much better shot of the optical encoder. There's the actual assembly right here. You can see that the detector is going to be on top, because going down to the bottom there's just these two leads on either side. That would have to be for the emitter on the bottom half of it, and then it shines light through the slots and going up to the detector, and it's probably just going to be a single detector, not a dual detector for quadrature encoding. It wouldn't need to actually determine whether or not the disk is spinning one way or the other, because it should already know which way it's spinning. The computer electronics on the main board should already know which way the tape is going just by telling the motors to go one way or the other. Alright, finally I'm going to have a look at the beating heart of the whole thing. A couple of Allen wrench screws. Takes it off, and there it is. There she is in all her glory. Finally focused. Alright, so what we have here is on either end, there's these two and those two. Those are going to be the write heads, and right in the middle, that's the read heads. And the write heads, I guess each one goes to one of these coax cable on this 2-row connector, and then the read heads, they go on the shielded coax cables with the shielded connector right here. And like I said before, when a tape goes in one direction, like this direction for example, it'll write with these two heads and then read with these two heads just for data checking to make sure everything gets written properly. And then when it hits the end of the tape, hits the end of the reel, then it'll start spinning the other direction and write with these two heads. And then again, check again with those two reading heads in the middle. And each time it does that, it shifts the stepper motor a little bit up and down, shifts this thing up and down on all the different tracks that are available on the tape. Now I figured, why stop there? Why stop just with the block by itself? So I took off the bottom base plate here and cracked open this back plastic panel where all the wires are sticking out. There's a whole bunch of glue all around holding it in place, and I already broke some of those wires off here. I'm just going to finish the job and break off all the others. There we go. So there's 6 individual slots there, and all the way down at the bottom of each slot is of course the read or write head that's in there, with 3 wires that go to each one. And then we can see the ferrite material where all the heads are, and you can see there's like a ferrite substrate right here, and then there's this arch that goes right there with some other ferrite filler right in there. I suppose that's ferrite in the middle. Got another arch here and an arch there, and even some ferrite splitter, just a bar, individual bar going up and down here. Each one of these ferrite blocks might have different magnetic properties. Not entirely sure about that. Okay, so that's the end of this teardown of a piece of computer technology which you might think is rather outdated, but is still quite relevant, because these cassettes are, or these modern day versions of this cassette, they've got extremely good capacity, like hundreds of gigabytes or terabytes even. You can store in something like this, and of course, you know, you can store a terabyte on a hard drive just as easily, but these things have a 30-year data retention life expectancy, whereas hard drive, well, you'd be lucky to get 5 years out of it. So if you want to back up your data for long term, then of course this would be the way to go. Or you could just back up all your stuff on cloud storage, because those big data centers, they keep all their stuff on tape too. They keep everything backed up on tape for long-term storage or disaster, any kind of disaster. You know, they got everything stored on tapes. Anyway, that's all I'm going to do for this. Thanks for watching. Please give it a thumbs up if you learned something, and I'll see you later. Bye.